last time.
So I think I'll just look at the photo and let's see if like okay, cool. Doing project around the time to last time to do the let's go buy because the guy please register my name. I don't know what they're doing. Hey Ryan, today is the extra 1 hour AIB, right? So it's
Today is what?
it's until 2 p.m. right?
Ah.
So what else is the teacher?
Sometimes. Scared, bro. You are shit, you are all the no nonsense.
Can't get the whip.
Okay, let's take attendance. Ashley, Avery here, Justin, Chloe, Ashley not here, Chloe not here, Cindy, not here, Calvin, Euler, Kumara, Ivan, Caden, Matthew Cheong, Matthew Yong, here, Matthew Cheong not here.
No, he's here.
He's here. Okay. Calvin,
That's the stretch.
Lashmina not here. Melton not here. Okay, Nakit here. Younger here. Nakit Kai. Okay. Ryan Lim. Ryan Ng. Javen. Not here. Alicia. Alicia. 20.
Eleven.
11. Okay, yeah, here.
Okay.
Not yet. Kid. Okay. Tuntut not here. Li Ching here. Trillis not here.
Number 7.
Okay, look at the red color. Make sure your name is red color. Take a look, I'm going to submit already. Correct. So many not here. Why every Wednesday so many people not here? I know my class is boring, but you are a student, you should come also. Okay? I teach a lot of different modules through the years. When I know the module is boring, I know it's boring, but no choice. Sometimes life you go through boring things. It's not always fun, always very nice, very interesting. Sometimes we have to go through a boring thing. This is one of them, I know. Okay, because programming not everybody's cup of tea. Okay, but just bear with me. Okay, it will be useful, not for everyone, but from our experience, it actually will be very useful for those students who wish to go for further studies in engineering in particular, but business sometimes they also now business a lot of AI thing also, and this might be something that we are going to be doing in your university if you go. Okay, from your feedback of your seniors, they actually say that they are one of the module in their university course is about AI, and what we taught here is cover at least more than half of what the module is doing. So they have a very good time taking the module because they really know all these things, right? Compared to their other counterparts, their peers. Okay, so it's useful. I mean, we know it's useful because but not for everyone. If you are not going to go into this line, then you will not use it. Okay, but it's good that you have a working knowledge of this. Okay, we will branch out to other things. Okay, and the knowledge is boring. I know it. Okay, because programming is not everybody's like to do that. Okay, but please bear with me and treat it as one of the things that some boring thing you have to go through your life. Okay, why I say all these things that some of your classmates now starts to appear to know they calculated. As long as my attendance is above 75%, I can only come. That's up to them, okay? But I'm quite worried because these few weeks, these two topics, the KNN, logistics, all these are very important in your assessment. Okay, you want good grades, you cannot escape this. Okay? Okay, so let's start the lesson today. Okay, lesson today, as I mentioned last week, right? I said today we extend 1 hour, right? Okay, but I do through our progress, no need, okay, because I'm trying to catch up with the other class. Now we have already catch up, okay, quite a bit. So we can, I will finish on time today, or even slightly earlier, maybe 12:45 like that, instead of extend to 2 o'clock, okay? So today, what I want to do, I want to also, like, stuff the thing down your throat, because it's not like every time you want to, get as many things as get it done and over with. I don't want to do that. I want you to understand the topic well. Okay, so I will not start the lab for this new topic today. Okay, you only go through the theory part and the tutorial part. Okay, so let's it won't take a lot of time. The lab part we are doing on next Tuesday. Okay. Okay, so today we start a new topic. Okay, it's called clustering. Okay, so far we have been doing supervised learning. Okay, new topic. So far we're doing supervised learning. So learning there is a Y and X. So there's so-called model answer for your model to learn. Okay, so they can build up the relationship between the input, the X versus the Y. So they learn, right? Like question and answer. So they learn, they do 10-year series, by past year paper and all these things. Then you give them a new question, you'll be able to answer. Okay, but now clustering is a different ball game. It's called the unsupervised learning. Okay, as the word implies, there is no model answer. All this algorithm do is just to group the data into different groups. Okay, so for example, you have been doing your let's say you're doing sales and marketing, right? Then the customers' data comes into you. Let's say there's 10,000 customers' data, right? With all sorts of data like their age, their gender, their occupation, their salary, blah blah blah, all this. Right? These are all your customers. But then you want to do a targeted marketing to a certain group of people. Maybe you are going to introduce a very high-end product, right? Then you only target those to have money, obviously, right? But also those who are willing to spend. Okay, got money and willing to spend is two different things. Some people very poor, no money, they're still willing to spend, right? All their credit card max out and all these things. So there are these type of people also. So how do you really group the customers into the group that you want to target? Okay, so it's using clustering. Okay, so clustering is very useful in this type of situation. There's a similarity between clustering and classification. Okay, so far until last lab, KMeans is all classification and supervised learning. Okay, but now we are doing about clustering, right? Is perform the grouping of data without the help of class label. Class label is the Y. Okay. Belong to which class? The lab we did yesterday, the class label is the pizza brand, right? A to J, right? Previously, the logistic, the class label is the yes or no, right? But now we don't have that. All the data comes in is X. Okay, Umaira, right? Okay. Nashmina. Cindy, right? Okay. Okay, so clustering, what are some of the practical usage? Okay, so you can see that, right? This is the first thing I said, right? To find common aspect of their customers, so that you can do a targeted marketing, right? Then this one also the social network, like your Instagram, your TikTok, all this, they actually use a lot of this also, right? From the behavior of you on the platform, let's say you always go through some type of content, okay, they will group you, okay? So they will group you to that particular, then they will keep bombarding you with all the advertisement and all the type of video that you look at, okay? So they use this type of algorithm also behind the scene, okay? Sorry, a lot of no voice today. Okay, so other things like image segmentation, medical imaging. Medical imaging is that when they do the MRI or X-ray, right? All the images comes in, then they start to group them into, this very serious case, less serious case, not serious case, something like that. So for them to manage, if there's a lot of this type of things coming in, this type of cases to handle. Anomaly detection, this one can happen in many different situations. Okay, in our course, okay, our this learning unit, we learn these two methods: K-mean clustering, hierarchical clustering. Okay, we'll do K-mean clustering today. Hierarchical is next one. Okay, so this is like a very simplified illustration of difference between classification and clustering. Okay, classification you can do very detailed clustering because you have the model answer. Okay, in this case, they cluster all the different animals into their group. Okay, no, classify. You see how classification? All the ducks in the ducks, all the chicken in chicken, right? So they can do that. But for clustering, it's not so precise because you don't have the model answer, don't have the label for you to do that. So for clustering, they can only classify birds versus non-birds. As you can see over there, right? So the chicken and duck is grouped together, and the turkey also, right? So this is something like that. Okay, so clustering not so precise, but they can help you to do it when your data do not have a label. Yes?
So it's just a more simpler version of classification now.
It's not simpler. Okay, classification have, what I should say, okay, maybe I'll put it this other way. When your data information, the data comes in with a label, which means that it's more refined. So for example, the data that we used so far, we have, okay, this is the input, the X, right? And this is the Y. The Y is the label, okay? So for example, just yesterday, the pizza, right? The pizza, the rate tells you, okay, this nutrition values, nutrition info, this is pizza A. This nutrition info, this is pizza B. They already tell you this. So the data comes in is more precise and more, there's more information inside. But for clustering is different. Clustering, it comes in, let's say without the A and B label, they just throw you a bunch of nutrition values without the A label A, and ask you to classify them into different type of pizza. Okay? So that's how you use clustering. Okay? There's no label for you to refer to. Okay? So if your data is not that organized, you should use clustering. Okay? Okay, so let's dive into the first algorithm called K-mean clustering. Okay, it also puzzles me why they always use the K to represent a very significant number. The Kn also, the K is the number of neighbors that you specify. The K-mean also, K-mean is the number of clustering you want to have. Okay, so you ask me how do I know how many clusters we want? Okay, that's the question that we're going to answer later. Just like K and N, the K, we need to go through the to do from K goes to 1 to 14 and find the best accuracy and use that one, right? That's how we find the optimal K. Okay? This one also, we don't know how many clusters we want. There's a method to identify it. Okay? So worst come to worst, you just run your algorithm a few times with different K. Then you see which one gives you a better result. Okay? But that's a very scientific method for this to identify the K. Okay? Okay, you can read now, but let me go through the picture easier, okay? Let's say this is your data, okay? And you want to cluster them. Actually, our human mind is very powerful one. Okay? You look at it, I can tell you in your mind, straight away you say that there's 3 clusters, right? Without even coloring, right? In your mind, you can do that. How our mind know that it's 3 clusters? It's always a mystery that scientists are trying to solve. Because if you throw this into an algorithm, they will not know one. They must go through some process before they come. But our eyes, the moment we catch it, the first second we know that there are 3 clusters, right? Right? So our human mind is very powerful. But then let's say you want to classify this, okay, based on the algorithm, okay, into 3 clusters, okay. So how do we do that? That's using the K-mean. Okay, these are the steps, okay. I will go through with you the actual step. You just read. Sometimes I think you give this type of flow chart or steps. You cannot understand because you need to have a picture in your mind. Okay, so I'm not going to refer this. You refer to this later after I show you the picture. Okay, so every time it's a picture in your mind that will help you. Okay, so let's look at it. Okay, Okay, what I'm going to present here is a graphical representation. But in actual way of doing it is not doing like that. It's the way that we do in the tutorial. Okay, so later tutorial I will show you. For the written test, this question always comes out. Okay, it is one of our favorite questions to set up, because this one will definitely test, will very specifically test your understanding of the algorithm, and it will test whether you are able to do it in a very short time, because it's very tedious. Okay, in the written test, it's open book. Okay, open book means that the time is very, very precious one. Okay, you have no time to fit your notes to understand a particular part during the test. Then you have no time to complete the whole test. Okay, so the time is very important. And this one, you're not familiar with it, you didn't try a tutorial, not understand it, you take up a lot of time. But once you know how to do it, okay, the time is just okay one. Your time is you'll get to it done very fast. Okay, so later I'll show you the tutorial. Let's look at the diagram method first. Okay, you have this data point. Same thing. Our mind will tell you there's two clusters, right? Very obvious. Okay, but then let's see the algorithm. Okay, so choose the number of clusters. Let's say you want to choose 2. Okay, you can choose 3 or 4, no problem one, right? You can do, but let's say we choose 2. Okay, so the very first thing is this. After you choose 2, you decided, okay, I want to have 2 clusters. Okay, then you randomly insert 2 points. Randomly, can be any points, to be the centroid of the cluster. Okay, what do you mean by centroid? Centroid of the cluster is like a center of gravity. Okay, I forgot to bring my bag today. I can draw. Okay, so basically is that the whole bunch of points. Okay, the centroid is the point where the coordinate. Okay, let's say for example, okay, don't look at the one. The one is 2 random points. Okay, let's say this cluster. Okay, the centroid is somewhere here, right? Okay, so this point, the centroid, the x and y coordinate are the average of all the points here. So let's say the centroid, you want to find the x coordinate. Okay, you get all the x, you add up all the x coordinate of all the points divided by how many points are the average. Okay, same for the y. So the x average and y average is the coordinate of the centroid. You get it? Okay, so that's the meaning of the centroid, the center of gravity. Right? Okay, so for 2 clusters, right, you randomly insert 2 points as the centroid. The centroid, definitely this is not a true centroid, it's just 2 random points. But later we'll converge to the actual one. Okay, so let's say we insert a green point and a yellow point as the 2 centroid of the 2 clusters. Okay, just 2 random points. Okay, you can also choose the existing data point as the centroid. Let's say I want to choose this point as a centroid and this point as a centroid. Also can. Okay, no restriction. Any 2 points. The only restriction is don't put these 2 points too close to each other. If you put 2 points very close to each other, you take a long time to converge to the answer. So usually the 2 points you spread it out. Okay, so you spread it out as much as possible. Then the algorithm will converge faster. Okay? So 2 points, 2 random points as a centroid of cluster 1 and cluster 2. Okay? The next step is, okay, then you calculate, okay, in this picture, okay, it shows that you, okay, pictorially, let's look at the picture. You join these 2 centroids. Okay? Then you draw a perpendicular bisector. Meaning that this straight line is perpendicular to the line that join these 2 points. Okay? So the perpendicular bisector means that it's like a center point. So any points that lies above the red line belongs to cluster 1, the green cluster. Any point below the red line belongs to the yellow cluster. This is to show you in the picture form. The actual way to do it is how? Actually, is that you calculate the distance of all the points to these 2 centroids. You know the distance so the distance from this point to here, this point to here. Okay? Then you compare. Which one is shorter? The shorter one is the one it belongs to. Okay? So for example, this point, look at my finger, this point. Okay? You calculate the distance from this point to the green one. So it's this distance, right? Then you calculate the distance from this point to the yellow one, this distance. So obviously this is shorter than this, right? So this point belongs to the green cluster. Okay? So you do this for all the points. Okay? Later we do it in the tutorial. Then you split them into two clusters already. Okay? Okay, this is using picture form is the same thing that I mentioned just now. Just calculate the distance. Okay. Okay. Now you found that all the point below the red color line belongs to the yellow cluster. The green one belongs to the green cluster. Okay. The next step. Okay. The next step is to calculate the actual centroid. Okay. These two are random point, right? Random point. Okay. Now you discard them away, throw them away already. Now you have your green cluster, right? These are the green cluster. Okay? You calculate the actual centroid of this green cluster. Also the centroid of this yellow cluster. Calculate them. Very easy. The x coordinate is x average, y coordinate is the y average. Okay? So that is the centroid. Okay? So now, okay, let's say the centroid are these 2 points, you calculated, so you shift the centroid to the point, okay? These 2 points. So now the centroid of this green cluster is this one. Okay, the centroid of this yellow cluster is this one, okay? That is the actual one, it's not the random point anymore. Okay, what do? Do the same thing. Calculate the distance of all the points to these two centroids. And the shorter one, okay, then the point belongs to the shorter one. Okay? But using picture, using a diagram is like that. It's the same thing, right? You draw a line joining the two centroids, perpendicular bisector. Anything on the right side belongs to the green one. Anything on the yellow side belongs to the yellow one. So now you see which point is changed. This point, right? This point previously it was being allocated to a green cluster. But after you find the real centroid, this point becomes yellow. And this point is slightly over here, so it's still green. Okay? So some points have changed their cluster. Okay? So the green one below on the left side of the red line will change to yellow, right? Yeah. Okay. Now after you change already, right? This point previously was green, now become yellow. So now the cluster change again, right? The cluster change again because there's some points shifting here and there. You do the same thing again, repeat the process, calculate the centroid again. Okay, now the centroid, okay, move already, right? Move away. The yellow move a bit up, okay? Now it's the new centroid again. Okay, repeat the process, right? Calculate the distance of every point to these two centroids. Okay, in the diagram is like that, right? Now you see that, very obvious, this point now belongs to yellow. Previously it belongs to the green, right? So there's still some movement, right? Okay, so now this become like that. Okay, when do you stop? You stop, okay, now you calculate the new centroid again, okay? Now you calculate the new centroid again, then you do the same thing. When do you stop? You stop when there's no more movement. You stop when all the points, after you do one more round of centroid calculation, all the points still remain in the various cluster. There's no movement of changing green to red, green to yellow or yellow to green. No more. Then you stop. Okay? Then your cluster is complete. Okay? So I repeat again, the algorithm is quite simple. Okay? You have a bunch of data, right? You decide how many clusters you want. Okay? How do we decide? Later I'll show you. Okay? Let's say you decided already. Then let's say 2 clusters or 3 clusters. Then you randomly insert 2 points for 2 clusters, 3 points for 3 clusters as the initial centroid. Then you calculate the distance of all the points to all these 2 or 3 centroids, and the one that is the shortest distance belongs to that cluster. Okay? Then you calculate the actual centroid of the cluster again, repeat the process until there's no more movement of points. The cluster remains as it is, and then you stop. So you get a cluster. Okay? Very quite intuitive, this method. Okay, it's not that difficult to understand. Okay, so now we discuss the issue. First, any question? Is the algorithm very clear? Again, later we do the tutorial. I'll go into review all this thing again. Okay, so now we tackle the question. How do you know how many clusters to choose, right? So the number of clusters we choose for a given data set can be any number. You decide how many clusters you want, okay? For instance, we may have chosen like k equals to, okay, k equal to 1 is ridiculous. K equal to 1 means that nothing will be done, everything is one cluster. So k equal to 1 is out of question, at least 2, okay? Or k equal to 10, right? 10 cluster, you can do that, right? But is it meaningful? Right? Too many clusters also maybe not meaningful, right? For your purpose. So how do you decide? Okay, this data, these two cells are the same. The left and right are exactly the same points. The first one, I do into 2 clusters, right? Can, right? No problem. I can also do into 3 clusters, right? Also no problem. So this is just to illustrate that the number of clusters is not predetermined. You can decide one, okay? But there's a way to find the optimal, okay? Okay, to understand how to find optimal, I have to introduce one term, okay? One calculation, one term that you need to understand. Okay, it is called it's the one matrix, one measurement matrix. Okay, it's called the very mouthful within cluster sum of square, WCSS. Okay, basically you refer to the name within the cluster sum of square. Okay, it means what does it calculate? Okay, so let's say for example you have 3 clusters. Okay, each cluster has its own centroid, right? The cross is the centroid. What do? You calculate the distance within the cluster, within the red cluster, all the red points, the distance to the centroid. Okay? Then you sum it up. Or you square it, then you sum it up. Okay? You do the same thing for the green cluster. All the points, distance to the centroid, square them, sum them up. Same thing for 3 clusters. Depending on how many clusters you have, you do the same. Okay? Then you add them all up, this is called the WCSS. Okay? So there's some characteristic of this WCSS that help you determine what is the best optimal cluster. Okay, when we say optimal cluster, okay, I want to qualify this a bit. Optimal cluster, what does it really mean? It really means that is the most logical way of grouping this bunch of data. Because this bunch of data, you can group into 2 groups, 3 groups, 4 groups, no problem. But the optimal cluster means that by grouping that, okay, the improvement from, okay, for example, now we have 3 clusters, okay? The previously it was 2 clusters. Then after that is 4 clusters. So number 3, why do you choose number 3? Because number 3 is the best improvement from 2. And after 3, the improvement become very little. Okay? That's why we choose 3. Okay? This one will bring us to the next thing we are going to discuss. Why do we use WCSS to determine? Okay? I will explain this again when we see the picture, the diagram later. Okay, to test your understanding of what is WCSS, let me review one more time. A bit low-saw, a bit long-winded today, but this one is the important concept. So I want you to understand. Okay, I explain one more time. Okay, then the next 2 slides will test your understanding. Okay, see whether you can answer. What is WCSS? I repeat one more time. Let's say you have 3 clusters. Okay, the red clusters, you calculate all the red points distance to the centroid. Okay, then you square them and sum them up. Okay, do the same thing for all the other clusters, then sum the whole thing up. Okay, so that's the definition of WCSS. Okay, within the cluster only, you don't go and calculate the distance from the green point to the red centroid. No, don't need. Okay, don't cross cluster, just within the cluster. That's why the name called within clusters. Okay, now the question is this: we have all the data points, the same data point, exactly the same, left and right are the same. But for the first one, we cluster into 1 cluster. The second one cluster into 3 clusters. So the question is, which one have a lower WCSS? Okay, by the way, WCSS, the lower the better. Okay, the lower, what does it mean? Lower means that the points are being concentrated nearer to the centroid. Okay, you kind of think of it, this one a bit, need you a bit of doing your mind stretching a little bit. If the points are closer to its own centroid cluster centroid, what does it mean? It means that this cluster is more distinct compared to another cluster, because they are more, they go towards the centroid. So they are more cluster, they are more compact, right? To the other clusters. Okay? If WCSS is bigger, means that the points are further away from the centroid. They are not so compact. So the clustering become not very clear, very vague. You know what I mean? Okay? So the question is this. 1 cluster versus 3 cluster, which one got the WCSS that is lower? And it's always true one. Anyone? Okay. You're either watching on your computer, your phone, or you stare blankly into the air. Okay? Nobody is really got eye shy that know that you know the answer, but nobody is doing that. Anybody know the answer? Don't be shy. Share with your friends. Which one? Okay, a show of hand. I'll everybody participate. No, some of you looking at phone that you don't want looking at. Okay? I want everybody to participate. Because this one, I want you to get this idea clear. Who said this one got lower WCSS? 1 cluster. Who said 3 cluster? Show of hand, show of hand, show of hand. Okay, you're right, 3 cluster. Okay? The more cluster you have, the lower is WCSS. You think of it, actually it makes sense, right? You see all this, let's say this point, you calculate the distance from this point to the central is very far away. Okay? But if you cluster them even smaller in smaller cluster, okay, the distance from it to its centroid must be shorter, right? So when the number of cluster increase, WCSS decrease. Okay, that is for sure. The next question, okay? What is the value of WCSS if the number of cluster equals to number of points? In this case, we have 16 points. 16 points, I say 16 clusters, right? What is the WCSS? If you understand what the definition of WCSS is, you will know what's the answer. I got 16 data points. I say I want to choose 16 clusters. What does it imply? What is the WCSS? Anyone? Can answer? I give you 5 marks. No, just kidding.
What's the question again?
Okay, the question one more time. Okay, time to wake up if you have been sleeping. Okay, 16 data points here, right? And I want 16 clusters. What is the value of WCSS? Anyone? Okay, you won't get 5 points from me, but you'll get my good impression. Anyone? 0. Yeah, I put it somewhere? No, right? Okay. 0, correct. Because if every point is its own clusters, definitely is its own central also, right? So the distance from itself to itself is 0. So if your number of cluster equals to number of points, then your WCSS is 0. So the WCSS you plot, the WCSS value versus its number of clusters, eventually you go to 0 if your number of clusters equals to number of points. Okay? Okay, so we understand what it is. Okay, so now you understand all this. I can explain excuse me, this graph. Okay, this graph is called the elbow graph. Why is it elbow graph? It looks like a person arm bending like that. Then your elbow is so this is your upper arm, this is your lower arm. So your elbow is somewhere here, right? Okay, so using elbow, this graph, WCSS is the value over here versus the number of cluster. Okay? So if you use this graph, the elbow method tells you that the optimal K, the best K, best number of cluster that you can have is at the elbow. So imagine this is the arm. Okay, where is the elbow? Elbow should be here, right? Okay. Why is it that this elbow here is the best? This is what I said just now, right? You see, from here, from cluster 1 to cluster 2, there's a great improvement. Decrease in the WSSR, very big improvement, right? Then from 2 to 3, there's also a very good improvement. But what happened after 3? The improvement taper off already. The improvement become very little, right? Very small compared to the previous improvement. Okay? So what does this mean? This means that with 3 cluster, this is the best number of cluster that classify the groups into distinct cluster, distinct group. If you go beyond this, you still can do, but they start to be very the distinction of the group become a bit vague, a bit ambiguous already. You still improve the WSSR, but then it's like a bit enforced, right? You force it to have this cluster. It's not natural anymore. So it's at this point that it's very natural that you group into 3 groups. I give you one, and the example is this, the previous picture, this one. These are the bunch of points, okay? Our human brain, as I said, is very powerful. Look at it, you will naturally group into 3 groups, right? This one group, this one group, this one group, right? It's very, very easy for us to understand because there's a big gap between here. There's a big gap between here. There's a big gap between here. So naturally, this is one group, one group. So if you plot this elbow curve on this, you can see that it's very distinctively at number 3, it starts to taper. Because what if you want to go into 4 groups? Okay? It is the 3 groups. Let's say you want to go into 4 groups. What will happen? You will force some of the points to become one group. For example, maybe these 2 become one group by itself, right? So to make it into 4 groups. So if you as a human, you look at it, it becomes like, it's not natural, it's not organic, right? It's like enforced one, enforce it to become 4 groups. So the WCSS graph actually tells you this. Okay? At number 3, it good rate improvement. Okay? Beyond that, it starts to be like a bit of very contrived, very not natural, right? Then improvement is still there, but this is not what we want. Okay? So you should choose 3 in this case. You get the idea? Okay? So this is called the elbow method. We're going to use this for the lab and also for our written test. Okay? But you ask me, this one also judgment, right? How do you know? I can also choose 4, right? Who are you to stop me to choose 4? Right? I can also argue, this one also improvement, things like that, right? We can also do that. But there is a scientific method, which I'm going to show you only, but I'm not going to test you. Okay? How to do this. Okay, there's a scientific method. Okay, sorry, this slide is still about the elbow. Okay, it shows you that you see from point 2 to from 2 cluster to 3 cluster, the improvement is a lot, about 1,500. Okay? Okay, the decrease is about 1,500. But from 3 to 4 is only like 500. Okay? 4 to 5 even lesser. Okay, start to taper off already. Okay? So very obvious, you choose the one that is the elbow. Okay, in mathematics it's called the inflection point. The point where the gradient changes a lot. Okay? Start to change a lot. Okay? So before that the gradient very steep. Beyond this point the gradient become very, very, very small. Okay? So this is by your eyeball and your own judgment, which one is the best cluster, number of cluster. But there is a method, there's a method, mathematical, geometrical method. Okay? More scientific one, but not expect you to do all this. Let me show you. Okay? So the method is this, I'll just explain it one time. You join point 1, P1, right, first cluster, to the last one, whatever plot you have, 8 can be 9. But you already know that it cannot be point 1 or it cannot be point 8, right? You already know. There's nothing in between. What do? You join these 2 points. You see the red line? You join. Okay? Then you find the perpendicular distance from all the other points to that red line. So basically, is this line is for 2, this line is for 3, this line is for 4, and so on and so forth. Okay? Then you pick the one that gives you the longest distance. Okay? You pick the longest blue line. In this case, it's 3. Okay? So that's the formula over there, right? The distance. Okay? You don't have to worry about that. Not to be tested. The formula is basically finding the area of a triangle. Okay, you can find the area of a triangle using the 3 coordinates. Okay, you go and Google search, you can find it. Anyway, when you massage it a little bit, right, manipulate a little bit, this is the answer, and this is the formula. Okay, x0, x1, x2, y0, y1, y2 are all the coordinates. Okay, after you do that, right, you can find that the distance is listed here. You can see that number 3 is the highest, 3.83. Okay, so that is the optimal K. So this is the more scientific method. We are going to do this in our lab also, but the code is there for you to. You just code the formula. That's all only. Okay, nothing special. Okay, so it will. You only use this method if you cannot tell very clearly which one is the optimal K. For example, if you thought that 4 also quite good, okay, then you might want to do this to confirm whether it's 3 or 4. Okay, in this case, number 3. So K equal to 3 is the maximum, it's optimal cluster. Okay, any questions? This is the end of the theory part. I'm going to go to the tutorial, but I give you a break now, 10 minutes. Okay, come back, we will start the tutorial. Okay, I will explain to you the tutorial. Pay attention to the tutorial. Okay, there's 2 questions. First, you're given the same points. Okay, let me show you. I'll come back in a while. Okay, there are 2 questions. The data points are the same, but the first part is to cluster into 2 clusters. The second part is to cluster into 3 clusters. Okay, so I will go through the 2 cluster one with you today. I want you to go back and try the 3 cluster one. Try at least once before the actual written test, because the question will be similar. Okay? So I give you 10 minutes break. Okay, then I will come back. Okay, I go toilet. 10 minutes break, come back. continue? Rainy day, I go to sleep. I also want to sleep. And let us finish this quickly, then we can go and take the rest, okay? Okay, let's do the tutorial 3, question 1. Okay? Question 2, leave it for you to do the 3 clustering one. This is exactly the same but more tedious only. Okay? So let me explain the question. Okay, you have 8 points. Okay, point A1 to A8, right? By different color over here. You can see, okay? So all the dots are. Okay? Their coordinate are given here. This is the x coordinate, this is the y coordinate. Okay, all given there. So you are supposed to perform K-mean clustering to cluster these points into 2 clusters. Again, our eyes, our brain can help us cluster already, right? You can see that this 4 points is 1 cluster, right? This 4 points is 1 cluster, very obvious. Okay. Later when you do 3 clustering, 3 cluster, then it's not that obvious. But 2 cluster very obvious, right? Okay. So how do we do that? Okay. The very first step is to arbitrarily choose 2 centroid, right? Because 2 cluster. These 2 centroid can be anything. Okay. But try not to put them too close together. Okay. Then it will take a long time to converge. Okay. So in this case, we already tell you. Okay. In the question, can use these 2 points. B1, 4, 6.4. This is the triangle. That's the triangle. Okay. Then the other centroid, the initial centroid, is 7, 7. Right? The cross over there. So let's begin with these 2 arbitrary centroid that we anyhow choose one, right? Anyhow choose. Okay. So how do you do that? Okay, the table here is empty. This is the answer. Okay, this answer I take a picture also can, but I think you will upload it. You'll be uploaded very soon. Okay. So let me okay, take a picture first. Okay, for this type of question, if you come out in the exam, okay, you are expected to show 1 working only. 1 working. Okay, the rest you just press the punch your calculator to get answer. Okay, let me go through this table with you first. What is this table is about? On these 3 columns are the one that we shown just now, the actual 8 data points and their coordinate. Okay. Okay. So there are 2 clusters, right? So one is a triangle, which is the B1. The cross is the B2. And the triangle and the cross, coordinate are given here, right? B1 and B2. So what you need to do, you calculate the distance from A1 to B1 using the equivalent distance, the square root of. Sorry, I forgot to make my marker. I came in from other meeting, so I can't no time to go back to get my marker. I'm sorry. Just I think you know what I'm talking about. So basically, it's the square root of this square root of 4, right? 4 minus 2, right? Bracket square. That's the x1 minus the x up, right? Then the 6.4 minus 4 square. Then you take the square root. Okay, so that's the distance, the equivalent distance. Okay, you should get 3.12. Okay, that's the distance from B1 to A1. Okay, do the same for B1, sorry, from B2 to A1, which is 5.83. Okay, after you get these 2 distance, right? Okay, we don't care about the WCSS first. We don't care about this first. Okay, you do the same for all the points. Okay, you calculate the distance from A2 to B1, A2 to B2. These 2 values. Okay, you calculate the distance of A3 to B1, A3 to B2. Okay, I think you get the idea. So you calculate every point, and so there are 2 sets of distance. Okay, from each point to the 2 centroid. Then based on the distance, choose the one that's shorter. So for A1, 3.12 is shorter than 5.83. So A1 belongs to cluster B1, the triangle. So we put over here, cluster B1. You get it? So you do through the whole thing, then you will see that. Okay, this is how you cluster. From point A1, A2, A3, A4, and A6 belongs to cluster 1. A5, A7, A8 belongs to cluster 2. Okay? Based on the distance.
Okay, you can see. Okay, the next step, okay, the WCSS is actually not required because WCSS is help you to decide how many cluster you want, right? But you already know you want to choose 2 lah. But for the completeness of this exercise, we calculate also lah. So what is this thing here? Okay, remember the definition of WCSS is the point, right? Every point in the cluster, the distance to its centroid, right? Then you square them and sum them up. Okay, so you look at here. After you know the clustering, right? Then you look at, let's say this B1. So point A1 belongs to B1. So you choose the distance 3.12, you square it. Okay, you get 9.76. Okay, for point 2, 1.17, you square it, you get 1.36. Okay, you do the same until the 0.5, 0.5 belongs to cluster 2 right now. Because it's shorter than this one. So it's B2, right? So you do not square this, you square the one, square the distance, 2.24. So you get 5. 2.24 square happen to be very close to 5. Okay? Then do the same for 6, then this 2 is 1 because the distance is 1, right? So you square it, it's still 1. Okay? So you see all the 0 are, okay, actually you shouldn't put 0, should be empty. Empty, the 0 should be empty. Because you are not calculating that. Because this is the distance to the cluster 1 centroid, but this belongs to cluster 2. So you don't have to calculate this at all, right? So all the zeros actually should be blank. Okay? Then what do? You add up all this, everything add up, right? All these values add up. This is the WCSS. Okay, 2 steps. First step is the distance calculated, right? You choose the one that is the cluster. Okay, this is the distance of the point to the cluster centroid, which is that one, right? Then you square it and put it here. Okay, after you do everything, you start them up, and this will be your WCSS. Okay, not necessary for our purpose here, but just to completeness, we do that. Then you can compare the next iteration, the WCSS should decrease because the centroid getting back more and more close to the actual one. Okay, so it will decrease. Any question? Okay, quite straightforward, right? Go back and look at it again. Okay, I will repeat one more time on the next step. Okay, so you can get a better, clearer understanding. Okay, so after you do this, right, what's the next step? After you have clustered, right, remember the step, let me show you. Right, this is the step where you calculate all the distance to these 2 centroid, arbitrary centroid, then you classify them, right? Then you cluster them. After that, what's the next step? You calculate the actual centroid, remember? Actual centroid of the green one, actual centroid of the yellow one. So it's the same thing you do here. So now you have a cluster B1 is 0.1. Look at this column. The cluster B1 is 1. Cluster B1 is 1, 2, 3, 4, 6. Right? Cluster B2 is 5, 7, 8. Correct? Okay, so now you based on the coordinate of all the points, calculate the actual centroid. Okay? So how do you do that? Okay, so now the actual centroid, okay, you find the average of the x coordinate of all the points in the centroid, in the cluster. So cluster 1, we have 1, 2, 3, 4, 6, right? So there's 5 of them. So this is the x coordinate of the point A1, A2, A3, A4, and A6. Okay? You find the average is 3. Do the same thing for y coordinate. These are the coordinate, y coordinate of A1, A2, A3, A4, A6. Then you find the average is 6.4. Okay, so 3, 6.4 is the new coordinate of your, new centroid, the actual centroid. Okay? If these 5 points is one cluster, that is the centroid. Okay? How about cluster B2? Cluster B2 only 3 points, right? 5, 7, 8. So you find the x coordinate average, right? 6.33. The y coordinate average is 8. So 6.33 comma 8 is the centroid, is the coordinate of the new centroid. Okay? So based on these two values, 3 comma 6.4, 6.33 comma 8, repeat the process. Okay? Okay, now the centroid, okay, shift to these 2 points. Okay? The x here is the center of these 3 points. The triangle here is the center of these 5 points. Okay? Currently, this 6 it still belongs to the cluster here. Okay? So you repeat the process. Okay, now instead of using using this one, okay, using this one, no more, these two no more. Now we base on this coordinate 3, 6.4, 6.33, 8. Repeat the process. Okay, so now you calculate the distance from these 3 columns no change on, the data points don't change on. Okay, so it's in black color. So you calculate the distance from A1 to the new centroid. Okay, the B1 new centroid. This is the value. Then calculate the distance from A1 to the new centroid B2. This is the value. Okay, so you do the same for everyone. Now you look at the distance again. Okay, in this case, 2.6 is smaller than 5.9, so it belongs to B1. Okay, then you compare. Okay, everything is the same cluster except A6. Right? A6 just now belongs to cluster B1. But now, after the recompute of the centroid, you find that A6, right, is now nearer to B2 centroid. Okay, so now it becomes B2, no more B1. So now the after second integration, A1, 2, 3, 4 belongs to B1. A5, 6, 7, 8 belongs to B2. Okay? Then you go back to WCSS, do the same thing, right? For the first 4, look at the distance over here. Because it belongs to B1, right? Square them, put here. Okay? For the next 4 points, these are the shorter distance, right? So you square them, you put here. Then you add them up. This is your new WCSS. The previous one was 31, right? 31.2. Now after the second iteration, after the new centroid, now it's 17.08. So it's the WCSS decreased. Okay? This should happen now. WCSS increase now, then some steps are wrong. Okay? It should decrease. Okay. Now you get this ready, right? Now, what's the next step? I must finish, because you haven't come to a point where you are sure that there's no point shifting ready. So you have to do one more step. Okay? Now, based on the new cluster, A1, 2, 3, 4, cluster 1, okay, calculate the new centroid. Okay? So now, instead of 5 points, now it's 4 points. So this is the x coordinate of A1, 2, 3, 4. Find the average. This is your x coordinate of your new centroid. Do the same thing for y. This is the y coordinate. Now B2 have 4 points also. 5, 6, 7, 8, right? So these are x coordinate of 5, 6, 7, 8. That's the average. This is for y. So now the new centroid is 2.5, 6 for B1. The centroid for B2 is 6, 8. Okay? Then you repeat the process one more time. Okay? Calculate the distance one more time. Exactly the same, I don't repeat anymore. Then you discover what? The clustering got no change. Second iteration and third iteration are exactly the same. There's no movement of the points to another cluster. Okay, first one we have A1, 2, 3, 4, 6, right? Versus 5, 7, 8. The second iteration, the 6 moved to cluster B2. So now we have 1, 2, 3, 4, and 5, 6, 7, 8. Then the third iteration, you find that all these points are unchanged, no change. Then that's where you stop, because that's where you get the answer already. Okay? So that is the answer. Okay? You cluster them into 2 clusters, and that's the answer. Okay? So these are the actual centroid of cluster 1 This is the actual centroid of cluster 2. And that is your final answer solution. Okay, in your test, you will be asked to find the centroid, the final centroid of your cluster. Okay, by doing through all this iteration. Okay, we won't make like wow, have to 4, 5, 6 iteration. No, okay, usually it's like that. 3 iteration we get answer already. Okay. Any questions? So that's the conclusion. So this show you all the iteration. The first one is A1, 2, 3, 4, 6. Okay? Then 5, 7, 8. The second iteration become A1, 2, 3, 4 and 5, 6, 7, 8. Then the third one, iteration 2, is the same. So you stop there. Okay? So this is the total number of cluster is 2, the 2 centroid value. Okay? Then the WCSS, you calculate the last one, is a slight improvement. Okay, remember this is 17.08. Okay, it reduces to 15. Improve. Okay? So the final is 15. Okay? So if you use the elbow method that we're going to do in our lab, the algorithm actually go through this. Then this is the ultimate value for the WCSS for 2 clusters. Then you do the same thing, repeat the whole process using 3 clusters. Then they come up with WCSS is for 3 clusters. When you plot, it should decrease. Okay? Okay. Same 8 points. You're supposed to do the 3 clusters. Okay? We give you the initial random 3 centroid, B1, B2, B3. These are the coordinates, right? This is the diamond, triangle, and the cross. Okay? So let me show you the final result. So this is hierarchical, this one. The final result is like this. Okay? As I have expected. They split the B1 to 2 groups. Because these 4 points are too compact together already. Okay, cannot split them. So like that. So you see this a little bit. Okay, so in this example, 2 cluster and 3 cluster both are actually acceptable. Our own eye we can see, right? Let's say you want to force it to be 4 cluster. Okay, how do you classify it? Right, look at it. You want 4 cluster. All the points, how do you put into 4 clusters? So you'll be very contrived, right? Very inorganic, right? Very unnatural. I would think that you will be forced to group these 2 as one group, then these 2 another group. Okay, so it becomes 4. Then it becomes not very nice because you know that these 4 points should be together, right? Okay, so this is what I mean that the improvement will be tapered off. If you go to 5, 6, then even more ridiculous. Okay, so I would think that this one is either 2 or 3. Can't tell. Okay, to be both are okay. Okay. Okay, since we have time, why don't you go and try out number 3? Then you don't have to waste time at home to do it. Okay. So now it's 12:17. I give you 20 minutes. Okay, to try 3 cluster. Tutorial 3, question 2. Take out a piece of paper and try, or do it on your whatever lah. You can do on computer. You want to do also can. Okay. I want to try this because I already told you this one will come on your test one. It's better you struggle a bit now, waste a bit of not waste spend a bit of time now. Okay, rather than during test you don't know what to do. I have students during test people ask me how to do this. Obviously they didn't go through the tutorial. Okay, and this can be easily 50 marks, 1-5. Okay, so I want you, okay, since that's all I want to say for today. I want you to stay back for 20 minutes, try out this one. Okay, then I'll go through with you very quickly later. Then we wrap this up. So next Tuesday we will start the lab. Okay, so whatever you are doing now, okay, assignment, whatever, watching video, whatever, please stop. Okay, try out this question now. Okay, thanks. Refer to your own thing because my computer no more battery so I'm going to shut it down. Okay, refer to your own question paper. Okay, I'll go through it in a while. is the x coordinate, 6.4 is the y coordinate, so it's different.
Here the y coordinate is also 4. Y coordinate here is also 4. Y coordinate here is 6.4. The y coordinate here should be 4 also.
What is the spreadsheet? No, this one, okay, sorry. Oh, I understand it. This is typo.
Yes.
Yeah, it should be 4 and 4, yeah.
Not sure.
Yeah, sorry. It's a typo, yes. Yeah, thanks. Oh, you have the spreadsheet to do it also, okay?